All right, folks, rise and shine and let's do some geometry with me. So I'm sending this one out Sunday morning because you have a problem set out of the textbook, and some of these questions can be pretty confusing, right? Can be pretty confusing to tackle kind of on your own. You've learned what the basics, right? You learned what SSS is, SAS is, ASA. But have you been on the lookout for a bunch of tricky scenarios? Probably not. Have you really learned how to do these in proofs yet? Probably not. Definitely not, actually. I haven't done any proofs with you. So normally these would be one or two questions that I would try to do in class. And then again, we would review homework the next day and talk about it in class again, yada, yada, yada. Obviously, we don't have that much time for homework review this year. Don't really have that much time to talk review in class this year. It's just we see each other an hour and a half a week, not like over 4. So anyways, I'm filming these videos here. We're going to do these problems, right? These are your examples. Rise and shine, do some geometry with me. It's Sunday morning. It's glorious. Let's get it done here. I know many people have already turned in the homework. Perhaps you're just watching this video or just checking out one or two of these problems you were a little bit less sure of here. So I picked these problems because I think they're kind of some of the harder problems on your problem set, but don't remember, it's not all the problems in the problem set, because if you look at the schedule here, right, if you go to this Google Doc, it's linked to on Google Classroom. You can find it. Let me know if you can't find it. I list out all the homework problems, and I list out everything that's going on the entire week, right? So we get to see if there's any vocabulary that came up recently, if there are any postulates that came up recently, if there's any like other vocabulary from earlier in the week that might be helpful. But most importantly, probably for you, your sake, is you get to see what problems you need to get done. And these ones here and these ones here. And I decided that questions 5 and 6 and 7 weren't that hard. Question number 8, a little bit trickier here. Actually, wait, number 15, written exercises here. I might actually do this. Oh, classroom exercises. Number 15 is where we're going to begin. And we're going to do a whole bunch of written exercises afterwards. These ones are very quick here, the written exercises. We'll have 2 proofs at the end, though. So 1 slow problem here, 2, 3 slow problems, a bunch of quick problems in between. Okay, so let's do this. Number 15, let's check out if we understand what's going down in this number 15 here. All right, so diagram here. That's very, very nice. Diagram is problem. I'm thinking maybe this is a proof. Maybe it's a proof. Maybe it's not a proof. Let's see here. It says explain how I'll prove the following. Okay, so this isn't exactly a proof. It's meant to hopefully get you ready to write proofs that are kind of like this here. So let's just see how we break it down. So perhaps because it's supposed to get ready to write a proof, I'd maybe think back to the things that I tell you to do when you write a proof. Step 1, when you write a proof, do what? Draw the diagram, right? Yeah, I'd highly recommend drawing this diagram here. Step 2, write the givens, write the proofs, spend some time with that, okay? So that's should be your step 1, step 2. And then after that, you can really come up with a game plan, okay? So that's part of the reason why I hate getting homeworks back from you guys that don't have a diagram drawn, don't have a given and proof statement drawn, because that doesn't show me that you're spending adequate time thinking about what the problem is. And you maybe just looking at it and be like, I'm not going to do this, and you're saying I can't do it. Draw the diagram out, write the given and proof statements down, and then that takes a minute to do, right? It takes a minute to do, and then, hey, you get some ideas during that minute you're actually doing it here. Okay, having the diagram here is especially important, right? That's probably more important than even really writing the given and proof statements. Having the diagram drawn is very important because you get to mark up the diagram, okay? So step 1 really is, like what we're going to do together, doing this example together, we're going to mark up the diagram with one another, with what we know is true, okay? What we know is true. So what I know here is true is that segment WH is congruent to segment FL. So this is WH right here. It's congruent to segment FL. Good. So we got some corresponding parts of triangles we know are congruent. Then we have some lines are parallel. So we also know that WH is parallel to segment FL. Okay, so I marked that one up here. Why is parallel lines good here? Why are they telling us that? Because eventually we have to prove triangles are congruent. So maybe let's come back to that in a second. Let's come back to that, okay? So let's think about this one here. One thing you might do in a problem like this to try to figure out how to prove this is you might say something like vertical angles are congruent, right? Because you're trying to get with one triangle to another triangle. Remember, you're really trying to get 3 things that are in common. Side, 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 or angle, side, angle here. So you might think, hey, I'm going to make this vertical angle congruent. I might want to mark that one up. I'm telling you that might not be the best idea, kind of think about this, because our goal here is we want to say that this triangle here, right here, is congruent to this triangle right here, right, FLY. So if I have a side listed right here, okay, if I have a side listed right here, I'm not going to use SSS to prove congruency here because I don't know anything about how these two sides relate, so I'm going to cross that out. So then you're thinking back, hey, look at what I'm going to prove. I'm going to prove congruent triangles. Let me work backwards. I'm going to need to either use SSS, or I'm going to need to use ASA, or I need to use SAS. Those are the three things here, okay? So anyways, this is a side here. We don't know anything about these sides here, so I'm gonna cross out SAS. We're not gonna use SAS eventually, okay? So remember, step one, mark up the diagrams, right? Mark up the diagrams, and then after you mark it up here, step two is to work backward, okay? Remember work backward? That was back from section 1.8. I told you about working backward. Working backward means find what it is you're going to prove and think about, well, what is it that's going to help us prove that? And what's going to help us prove that is ASA, right? ASA is going to be the way to get there. Okay, you with me? You with me? You following this at all? Hopefully you are. You just really have to look closely. Like really getting down to diagrams is really what you get out of this class, and being able to organize your thoughts and like a lot of information you have is really what you get here. So that's why I'm spending so much time on this diagram here. Okay, so check it out here. So then the question is, how am I going to prove these triangles congruent by ASA? What can I mark up here? Well, I have parallel lines, so that's nice here. I have parallel lines here. What do I have running down between those parallel lines? I have a what? This, my friends, line LH would be a insert text box. It is a transversal. Okay, a transversal. That's cutting across two, I'm going to mark it bigger here, two parallel lines, right? Two parallel lines here, okay? So that transversal is going to tell us that this angle right here, angle WHY, is going to have to be congruent to angle HLF. Why? Because they're alternate interior angles. Okay, so that's helpful there, right? That we have alternate interior angles. That's good. So now we have AS, right? An AS correspondence, right? So far, an AS, but that's not good enough. We need to get to AS, and then finally we need the last one. We need A. So then the question is, how do I know that that angle is congruent to that angle? Because that's the way we're going to prove this. That's the only way we're going to do it. We don't know anything about these sides, but we know stuff about angles because we have parallel lines. Okay, so parallel lines. Ooh, check it out. We have another transversal. Look at that. That definitely fits the definition of transversal. It's a line that intersects two lines, right, in two different places, right? One place right here, another point right there. So that fits the definition of transversal. It just so happens the lines are parallel, so that means that this here and this here are also, they're alternate interior angles. They're on opposite sides of the transversal, and they're in the interior of the two lines here. So that'll be the alternate interior angles are congruent based on if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay. So, anyways, now we need to just break it down here. So let's go ahead and just summarize this so we can get this down here as how I would do this. How would you prove the following? Well, let's see here. One, I would state my givens. First, I would state my givens. Okay. First, I would state my givens. Okay, which is this right here. So I'd state that. And that's great. Okay, then I would say that angle W is congruent to angle F. And because I use the same reason for both, I use alternate interior angles for both. So angle W is congruent to angle F. And I would say that angle WHY is congruent to angle FLY, because if two parallel lines are cut by a transversal, then alt interior angles are congruent. Okay. Cool. So then I have that. So now I would just say, just wrap it up with this. Now I have, right? I have that angle congruent to that angle, that side congruent to that side because it was given to us. That angle congruent to that angle for the same reason as the first angles I talked about here. Because if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay. So now I have found an ASA correspondence or congruence. Correspondence is how I'll do that. So the triangles are congruent by ASA. And we got that one done here. Okay, so you can write it out in letters here. If you want to write a proof for that one, that's totally fine too. If you actually just write the proof, but this is a little bit easier here. Look at, I got this done in what, 2 sentences or 3 sentences maybe. Yeah, say my givens. I would do that. This is the key reason to get the angles congruent, and then I would say that they're congruent by ASA. Boom, 3 sentences, you're done. You're good to go. Okay, going on a little bit quicker here. We got written exercises to decide whether a triangle is congruent to triangle ABC. If so, write the congruence and name the postulate used. If not, write no congruence can be deduced. Okay, so not all these pairs of triangles, for instance, are going to be congruent. We need to decide if these are congruent and what is the reason here. Okay, so I have some sides here. That's nice here. So in all these problems, it's either going to be SSS, SAS, or ASA. So that's what I'll start by writing it down here. Maybe narrow it down here. Okay, so I know with this here, just getting used to diagrams here, what I might do is mark up something that I know. Vertical angles are congruent. There we go. But this is ASS. This is ASS. Remember, you never use ASS as a reason unless you are an ASS. Thank you for Mr. Evans for sharing that line. I like that quite a bit here. Okay, so that's not really going to help us here. We don't know anything about how those 2 angles are related. Do we know anything about how these 2 angles are related? No, we don't really know that. So this one here, number 8, let me say, I think number 8 might be, so AS, yeah, I think this one is no congruence can be deduced. That's what I'm going with. I don't really know if that's right, but it's what I think right now, and that's why we have the Jamboard. We can check our answers on Monday. But I don't think anything can be, right? Because it's definitely not SSS. We don't know anything about these sides. Like, why would we say that those sides are congruent? Why would we say that they're congruent? No, we don't know that. It's not ASA because, again, we don't know if that side, that angle and that angle are congruent. We have no idea. We don't know anything. We don't know if this angle and this angle were congruent, right? We don't know those here too. So it's not going to be ASA or SAS, right? It's not going to be any of those here. So I'm feeling pretty confident about this one. No congruence can be deduced. That's what I'm going with that one. All right, number 9 here. Let's see here. So I might start. I'd recommend doing it this way for all the problems here as you guys get new to this, getting used to this now here. SSS, SAS, and ASA. Let's try to figure this one out here. We don't really know anything about the sides. We have one side that's congruent to itself. Here, this is a shared side. So check it out here. This side, so AC is shared, it's called a shared side, is a shared side of triangle ACG and triangle CAB right here, ACG and CAB. So the question is here, right, is that going to help us here? Do we have an ASA correspondence? ASA correspondence here. Let's check it out here. It says also write the congruence. So we actually have to do that. Save the congruences here because I think these will end up being congruent. Let's check it out here. So here, we don't know that these angles match up here, but what's this angle going to be, right? If this is 60, that's 59. They're all 180 degrees, right? So we're going to do 180 minus 60 is 120. Minus 59 would be 61. Oh, interesting. These 2 angles would then be congruent because that would fit the definition of congruent angles. They're angles with the same measurement. So we have an angle side correspondence so far. Question mark, what is this one going to have to be here? Well, this whole triangle is 180 degrees. 180 degrees minus 60 is 120. Minus 61 degrees, 120 minus 61 degrees is 59 degrees. So yeah, freaking yeah, we did it here. Yes. Okay, cool. So check it out. So now we have an ASA correspondence. Okay, we have an ASA correspondence. Okay, so I don't know anything about these sides and how they relate going into this. So it's not going to be SAS and it's not going to be SSS. The only side we know is this one, so it's got to be ASA if they are congruent here. Okay, so what I have to do is I need to write the congruence and name the postulate. Okay, so the congruence is the tricky part, I think. So angle GAC corresponds to angle BAC. So we need to make sure we mention the A's at the same time. And that actually makes it a little bit easier, I think. So triangle A, and I'm going to put this congruent thing here, and triangle A. So what I'm trying to do here, so I didn't write all 3 letters down here, and I didn't write all 3 letters down here, because I'm trying to map the correspondence here. This here, vertex A, has the same angle measurements at it. Okay, so this is 59 degrees, that's 59 degrees. So that means the A's correspond because the vertex A in this triangle and the vertex A in that triangle, the angle formed at both of them are congruent to one another. So they correspond to one another. Here, angle C's, yep, those correspond here. It's actually pretty easy to write out then. So C's, right, this is C here. So ACG, okay, is congruent to triangle ACB. And we know that because of ASA, of course. But I want to really point out here, this is really the unknown thing here was, well, this is AC, right there. Those match up. Okay, so A's are here, C's are there. Good, those are the same. G and B, right? These are both 60 degrees. Okay, so that's why the letter appears at the ends of the triangle name here. Remember, this needs to map up perfectly. This angle G needs to be congruent to angle B. Angle A needs to be congruent to angle A. Angle C needs to be congruent to angle C. And it just so happens that, yes, they are congruent. We're good to go there. Okay, so I wanted to point that out. And then the reason is by ASA. Okay, so that's what your answers should look like in this old section here. You got like 12 of these here, 13 of these here. These little puzzles. They're little puzzles. They're pretty sweet, guys. They're pretty sweet. They're a little overwhelming the first time you go through them, but like, hey, that's what it's all about. Is like breaking down puzzles, man. Sometimes puzzles just keep you up at night. You find it just so frustrating to have an unfinished puzzle, don't you? All right, let's check this one out here. We got parallel lines. Yes, parallel lines galore. Let's check this one out here. All right, again, am I doing SSS? Am I doing SAS? Or am I doing ASA? Let's check it out here. Well, I got a couple sides right there. That's nice. That's very nice here. I got sides here. But you know what? I'm going to cross out SSS. I don't think it's going to be SSS because why would we say this? And like, how would we know that those sides would be congruent? Let's put 2 tick marks there. How we know that would be congruent and how we know that these are congruent here. Like there's nothing here with parallel lines that would allow you to determine that sides were a certain length. That doesn't happen. What are parallel lines good for? Right? Parallel lines good. What are parallel lines cut by a transversal? What do they form? They form what? Congruent sides or congruent angles? Parallel lines cut by transversal form congruent angles, congruent corresponding angles, congruent alternate interior angles. Oh my, oh my, oh my, oh me, oh my. Yes, it's going to be either SAS or ASA here. If these are congruent too, let's see if we can just actually isolate this to figure this out, okay? Mark up your diagrams, friends. Mark up your diagrams here. So it's probably not going to be SAS because, again, we don't know anything with the sides. So it's probably going to be ASA if we can get it to work. I'll put a question mark here. So let's see if we can get the requisite number of angles here. So check it out here. I found a transversal. This is definitely a transversal here. AS is certainly a translinear, transversal. AS is definitely transversal because we have parallel lines. Check it out here. They don't have to be parallel to one another to be transversal, but there are 2 lines that this line here, AS, intersects in 2 different points. So we know that this angle needs to be congruent to that angle because those are corresponding angles formed by parallel lines cut by transversal. So those are definitely congruent. Okay, I have my congruent side here, Am I able to get that angle congruent to that angle? Sure as heck am, because that AS is a transversal of line BT and a transversal of line AC. Okay, so this position here and that position here, those are also corresponding angles. Okay, so these are congruent right here. These are congruent right here. Okay, that was a little bit fast, a little bit messy of a diagram. Feel free to come to office hours or ask questions or whatever if you have trouble seeing that one, because I think that one might be harder to see here. All right, we got to write the congruence here. It's going to be by ASA here. So triangle A. So angle A up top here. And angle, I don't want to call it B because we have multiple angles that are indicated at angle B. I might just be, but B is the vertex, okay? So they're going to correspond here. So I don't actually have to worry about naming that angle B. I just know that the angle in that triangle that's at vertex B is going to be congruent to the angle in this triangle at vertex A. Anyways, I'm just saying maybe a bit too much here. So, okay, so triangle A is congruent to triangle B. Well, no, the triangles have 3 letters. They're named by 3 letters here because there's 3 non-collinear points that form a triangle. So B, those correspond. S corresponds to B over here. Okay, so that makes it a little bit more complicated. S is down here, corresponds to B. Corresponds to B over here. Okay, so triangle ABC. Okay, A goes to B. B goes way down here to to S, and C goes to T, right? C goes to T here. Okay, so notice I got to do this in the order, right? A, B, C, B, S, T. They correspond, right? They correspond. They're in the same positions here. Again, angle C and angles T are the congruent ones. They're congruent to one another, so that's why they appear in the third position. Okay, I could have called this triangle BCA is congruent to triangle STB. I would have been allowed to do that because B would corresponds to S. So it doesn't really matter the way you order the three letters as long as they match up to one another. Okay, so that's by ASA. Good times, man. Triangles. It's all about triangles, building blocks. It's sweet. It's good stuff. All right, so this one's ASA. We're good to go. We got our answer here. Let's see if we get this one here, my friends. Let's see if we can do this here. You let me call in your friends? I don't know. Are we friends? We're enemies. No, anyways, it's a good time. We're just hanging out. We're just doing some work together this year. It's all good. All right, vertical angles are congruent. That's good, but that's not going to help us, right? We don't know anything about side lengths right here. So I'm going to go ahead and erase that. All right, so we know that this is definitely not going to be man, do we know anything about this one? We don't know anything. Do we know any? So S, it's definitely not SSS because we don't know any of the side lengths. It's not going to be SAS because, again, we don't know anything about the side lengths, right? We don't know if that's congruent to that, and this is congruent to this, or this is congruent to this. Is it even going to be ASA? Do we know any of the side lengths and how they correspond to one another? Yeah, it's not going to be ASA either. Okay, so you could, of course, right? These are alternate interior angles, right? You can mark those congruent. You can mark these ones congruent. They would have to be congruent if simply by those lines being parallel because AU and CV are transversals and the vertical angles are congruent. So you know that this is an AAA correspondence, but AAA ain't good enough for congruency, right? So just as a counterexample to show you that there's no way we can determine that these two triangles are congruent is if I draw it a little bit more dramatically in terms of size. So this is, let's make this VU. I'm going to do this down like this. And then I'm going to do this right here and make it parallel. Okay, so let's pretend here that, right, these are parallel lines. Parallel. These two triangles are clearly not congruent to one another, even though that angle would be congruent to that angle. And these are alternate interior angles formed by parallel lines. So those would be congruent. These would be congruent. Okay, so but obviously, so these would have the same kind of shape to them, but they would have different size, right? Different size. So this would not fit the definition of congruent angles here. Okay, so let's go ahead and write that one in. So we got it down. This one is no congruency can be deduced. Yes, no congruency can be deduced. Oh, what happened there? What is this here? Look at this garbage up here. That's no good. Anyways, my friends, I gotta stop saying that, right? My reg loves me, like just so you guys know that my reg loves me, but they don't like say, "Hey, friends, listen to me on this." They don't like that. They've said that, but they love me, right? Ask any member. Reg 2104 is a legit reg. We're fantastic. Anyways, all right, let's keep going here. These two triangles. How many more of these we got? Okay, we only got two more. And then proof time, proofy proof time after that. All right, let's check it out. You know, you're waking up for this. I got to get you awakened. Geometrically awakened and physically and mentally awakened for your Sunday. All right, let's check this one out here. Is triangle ABC going to be congruent to triangle CGA? Cool, we got a side. That's great. That's fantastic. Okay, we got this side. It's congruent to that side. So SSS, SAS, and ASA, they're all still in the picture here. Ooh, we have that side congruent to that side. I got another side. I found another side that I would know is congruent right off the bat. I got what? I have the shared side. That's right. Cue the shared side music. Shared side. Boom. Hooray. Everybody rejoices with the shared side. All right. So that means that this here, SSS, SAS, kind of still in play. ASA is definitely in play here because I have the sides here. But you know what? I got parallel lines right here and parallel lines right here. So my guess is that this is going to be SAS or ASA. I don't know which one yet. But it's not going to be SS actually because we don't know anything about BC and AG yet until we get the triangle congruent because we're going to get them congruent in this one here. All right, we got some parallel lines. That's nice. Parallel lines are just nice. We got some information here. All right, and we got those across here. Okay, and check it out. We got a transversal. Look, transversal time, transversal. Running along down. Boop. Intersecting those two parallel lines. Get the transversal right there. So these are parallel lines right here. So we know in this triangle and that triangle, we're looking here. I think we're looking here. A boom. A boom. And check it out, right? We have a side, we have another side, we have an angle. So that's two sides and an angle. And is that angle included between the congruent sides? SAS, SAS. Yeah, I think we're good to go. So this would be a side, okay, angle, side correspondence. Okay, we got our angle down here and we have our side down here. Okay, so we know for sure, right? So now we got to actually write the congruence, and that's the tricky part, right? This is definitely a tricky part to think about this thing exactly, is how these two triangles we would map up to one another, right? We would map up to one another. So we'd have here triangle C clearly goes with A because that's where the angles are. I would start writing it that way. Triangle C, and here triangle A, and then I think about this, right? So I have triangle C, the C's here, and maybe I would go where the common, yeah, you can really go anywhere with this, but let's go CG. Okay, let's do CG because CG clearly corresponds to AB, right? AB, because that side up top here, this one in green, congruent to that green tick mark down there, right? So CG, so let's do that. CG is congruent to AB. Oops, sorry, AB. And that makes our lives easier. We just need to complete this with the last letter, which is going to be B to back to C, right? Get us back to C here. And this is, CG gets us back to A up here. That's A here. And woo, we got it here. We got it here. So this is kind of confusing. This is one that I expect probably several people to get incorrectly the first few times through, which is fine, right? It's getting us to practice and pushing your thoughts and opening your mind and taking it all in. But we just double check that this is valid right now here, because angle A, right, is right here. Okay, right here is angle A, and this CGA angle A is right here. And angle C would correspond to angle A, and angle C is right here in triangle ABC. And yeah, those totally look congruent. They look like they're about what, like 60 degrees or so, 55 degrees. And more than this, like 70 degrees. I don't know. But anyways, yeah, I'm feeling pretty good about that. Angle B certainly maps to angle G. Look at that. Those are the ones that are off by themselves. They don't share the side or anything like that. So B and G definitely correspond, and then C, which is right here, and A, that's where we begin with. We correspond there. Okay, so our answer is this triangle CGA congruent to triangle ABC by SAS, my friends. SAS. There you go. SAS. We haven't said CPCTC in a while. I wish we had some CPCTC in action. All right, folks, we got this one. We got this one. Let's get this one figured on out. Okay. Options to choose from: SSS, SAS, or ASA. And let's check it on out. Check it on out. Check it on out. We have angles here. Ooh, we have an angle here. Very nice. We have a side. That's good. Do we know anything about that side length? No. Do we know anything about that side length? No. Not going to be SSS. Do we know anything about that length? Do we know anything about that length? No. So it's not going to be SAS. Is it going to be ASA? It's going to be ASA. That's the question here. So here, is my side included? Okay, so is it going to be ASA? That's now the question, ASA. So remember, the S is in the middle because that means the sides need to be included by the two congruent angles here. And check it out here, ASA. Is that an included side? Not really. This angle has nothing to do with this side right here. Okay, this side here. So this angle is not part of including this side here. If I knew that these two sides were congruent, then I could use ASA, because here I'd have ASA and here I'd have ASA. But no, I don't know that this side here and that side here are congruent. So I'm not going to be able to juice a congruency right here. Okay, so this is AAS, which right as of now, we know that that's not one of the choices we have here. So I'm guessing a few of you guys are going to come in on Monday being like having asked your parents, asked your older siblings you've taken this course before, and they're going to tell you that, yeah, oh yeah, they're congruent. Or maybe you looked up online, but we haven't proven AAS yet. We haven't proven AAS yet. We haven't been proven. I guess this would be AAS. There's another one here. There will be 5 different shortcuts we have eventually. So SSS, SAS, and ASA were all postulates that came up in section 3.2. We're going to have a couple theorems that we're going to prove, not next class, I think the class after that or the class after that. Sometime this, like maybe the end of this week, we'll do it. Before Thanksgiving, we'll get the final 2 reasons. But AAS will be one of them. But as of now, nope, no congruency can be deduced, my friends, can be deduced. All right, friends, let's see here. We got a proof now, guys. Let's just do this. I'm rolling the dice here. I did this 2 ways. I was like, you know what? We could have this awkward kind of like fill in the blank proof right away, but that'd be boring with Mr. Fortin. Like, I don't like fill in the blank proofs. I just don't. I think fill in the blank proofs kind of like box you into like what you can say, and you don't really like think about them when you're doing them. You're just like, wait, I'm stuck. I don't know what this is here. No, let's get back to this here. Let's do this freaking proof right now. Because I think you just do this freaking proof because I've given you reminders of what to do, right? My series of 4 things to follow. Okay. Stay focused, stay organized. That's what mathematical organization is all about. In the 10th grade, when you're here in geometry, it's all about mathematical organization and being attentive to details here. And part of this organization is knowing how to plan a proof. Are the 4 recommendations that I have for you guys here. Step 1, use previous proofs for ideas on how to do it. Okay, so this one right here, right? What did I tell you about this? Like, work backwards is one thing here. These are triangles and congruent, so we're going to prove them congruent through SSS, ASA, or SAS, right? And we're thinking about like what we need to say to get those here. So that's important, right? Previous ideas, we had that proof at the beginning that we did that. Sometimes proofs are exactly the same as they are in other ones, like, so you can just do it again. But kind of most importantly in planning a proof when you're going to jump to this here is mark up the diagram. Do it. Mark it up with what you know. Think about what definitions and theorems you can use based on what you marked up, right? What is the things that I marked up that I know? What's that going to lead me to, right? In order to be able to prove what it is I'm trying to prove in this little puzzle that we have here. Proofs are just puzzles, right? Puzzles of justification here. And then just as important as step 2, which of marking up the diagram was step 2, is step 3, working backward from what you need to prove, okay? Look at what you need to prove and then think about everything you marked up so far, everything you've maybe said at the very beginning. How's it going to connect? How can I connect the beginning with the end? How do I connect the beginning with the end? Does that sound familiar? Does that sound familiar from English class, right? From English class or from writing an essay in social studies? Like, I know what I want to say at the beginning. I kind of know what I want to say at the end. How do I connect them? How do I provide a convincing argument? And this is what it's all about, man. So it's all about staying organized mathematically and freaking arguing with one way you can't be argued with at all in the future. All right, so let's check this out here. We got plane M. This is plane M right here. Okay, one thing I haven't really said yet is that, check it out here. My diagram here is in green. Earlier diagrams, they were in color. We saw some red for the marking like parallel line stuff, but they were black and white, right? They were black and white. Even this one here, which was kind of a proof, it was in black and white. Oh, hello, Rise and Shine, son. How are you doing? But we have this diagram in green. That means this is in 3 dimensions. It's not a planar figure we're looking at here. We got multiple freaking planes going on. That's right. We got planes crashing in with one another, right? This is a surface right here. This here would be a different plane, right? What's twisting here, a different plane, because the plane's shooting off like this here with this side of this, and then this is a plane like this. So basically we have here in this diagram, because it's in green, we basically have one plane. We have one plane crashing into another plane, right? It's a convergence. They're 2 planes that intersect. So remember, planes can either be parallel or they can intersect with one another. So we have like this sort of like triangle of a plane intersecting with what is another plane, plane M. We want to make some observations about this based on what we know about how that triangle is intersected with plane M. And that's how your puzzle begins. That's how it is, right? Statements, reasons, we'll put them down too because we got to get them there eventually. But remember the 4 things that are required for a complete proof, okay? Make sure you copy down the diagram. That's pretty key, right? Right? You can't get full credit on the homework if you don't copy down your diagram, right? You got to give yourself a shot on this one here. So I got statements, reasons, copy down your diagram, and also copy down your given and your proof statement here, okay? Your given premises and your proof statement here. Just copy it all down, and that gets the juices going. That gets you thinking, right? Gets you thinking right here. All right, so let's do this here, and then you can write the proof. You copy down the diagram, you write the givens and proofs, because you can mark it up, right? Mark it up is going to help you tell a proof. You got to rewrite the freaking thing. Let's get this. All right, plane M bisects AB. All right, so bisects AB. Interesting. So that's going to unlock this for me. I'm still going to have to say it in here, but if plane M bisects AB, then that means O is going to be the midpoints, right? Going to be the midpoints of segments AB. Okay? Because a segment bisector, right? A segment bisector is a ray, is a line, is a plane, is a line segment that intersects another segment at its midpoint, right? At its midpoint. Okay? That is the definition of a segment bisector. Okay? So that is a one you can oftentimes forget about because that was in the second section of the year when you knew nothing about geometry. Definition of segment bisector. So, anyways, that's the idea here. Segment, because we know that plane M is a bisector of segment AB. Then we know that where it intersects segment AB, which is point O, is the midpoint. And that's going to help us get to that AO is congruent to OB, right? And then we get to go there. Okay, so we have a couple sides of the triangles congruent because now we're thinking. Well, we're not thinking backwards yet. Hold on a second. Let's mark up everything else we know. We know that PA, okay, PA is congruent to PB. So I've marked that one up here. What is it I'm trying to prove to? What am I trying to get to? I'm trying to get to the two triangles, triangle POA, and triangle POB are congruent to one another. That's my goal. Question mark, question mark. So now I'm thinking game plan, right? I'm thinking game plan. I have already just through marking it up. I haven't said anything yet in the proof, but just by marking it up here, I have a side congruent to another side congruent to another side, and we're trying to get triangles congruent together. So my strategy is, am I going to do this through SAS? Am I going to do it through ASA? Or am I going to do it through SAS? And I'm going to see if I can mark up the whole darn thing. Well, ASA, do we know anything about the angles in these diagrams here? Do they give us anything about angles? Well, they just give us congruent segments. They give us segment being bisected. No, we don't really know anything about angles. So I'm going to cross out ASA, and I'm actually going to cross out SAS because how would we be able to prove that angle A is congruent to angle B, for instance? They don't give that to us. They don't give me parallel lines or like that. So if they don't give you parallel lines, they don't give you congruent angles, you're really not going to use ASA. You're not going to use SAS. You're going to use SSS here. So let's maybe look a little bit more closely at this. This is sort of the puzzle of like looking at this and seeing if you really get. This is one where you can really get before you actually start writing it. Wow, how do I know that that last side is congruent to one another? The last side's congruent. Well, check it out. PO is in both triangles. Right? It's in both triangles. So PO is in both triangles. That means it's congruent to itself, right? That's congruent to itself. So that's why the reflexive property was a property that came up in chapter 1 because, right, guys, in order to use the SSS right here, this postulate here, we need to say that 3 sides of one triangle are congruent to 3 sides of another triangle. And in order to do that, you got to use reflexive there to say that PO is congruent to PO. All right, folks, let's do this so we can get this and get on with our merry way, continue the rest of our Sunday. Plane M bisects AB, and PA is congruent to PB, and that is a given premise. Given premises, there are 2 of them. Right, we're got a semicolon here. Okay, so then I got that. Okay, I've taken care of those sides here. Have I said that AO is congruent to OB? No, I haven't done that yet, but maybe I'll just do the PO one because that's really quick. We can knock that one out of the way. So I want to say that PO, distance PO is equal to distance PO. And I could have said that the segments were congruent, but you also say that the distances between the 2 endpoints are equal. And that's fine too for using SSS or ASA or SAS. So that means the same thing. It's really that they're congruent, but we're just saying that the lengths are equal. So that is the reflexive property. Reflexive property of equality. And I'm going with equality because I said the equality of the lengths, not the congruency of the segments here in the statement here. Statement 2. Okay, statement 3 is I want to get to that AO is congruent to OB or that AO equals OB is probably what I'm going to say here. But we have here plane M as a given premise here. Plane M bisects segments AB. And we haven't done the work yet to show that we know that AO is equal to OB. Well, first, what is a bisector? Like, what is the segment plane M bisects AB? What does that allow us? What do we learn about point O, for instance, because plane M intersects segment AB? We learn that O is the midpoint. We learn that O is the midpoint. So, but if plane M bisects segment AB, remember a segment bisector intersects that segment at its midpoint. That's how something gets bisected. Sure, it's going to create two congruent segments based on going through that segment. And if it's a bisector, but the reason why it does that is because it goes through its midpoint. A segment bisector is a ray, a plane, a line, or segment that intersects another segment at its midpoint. Okay, so that is enough to establish this information right here. Plane M bisects segment AB is enough to establish that O is the midpoint of segment AB. And I'll go ahead and circle that guy right there. Boom. All right, folks, let's keep doing this, jamming this here. That is a definition of segment bisector. All right, number 4. Well, if O is the midpoint of segment AB, what do we know about AO? What do we know about OB? Well, they got to equal each other. They got to be the same length, because if O is the midpoint, it's going to create two segments of equal lengths out of segment AB here. Okay, so that is definition of midpoint. Okay, so remember, proofs work a lot of the way where it's just like one step at a time. How does this statement get us to a new statement here? And then how does this statement that I just said as a consequence of statement 1, how does that get us to a new statement we can write here? Well, that would be the definition of midpoint. If O is the midpoint of segment AB, then AO is equal to OB, right? That's part of the definition of midpoint right there, and we're good to go. Okay, so now I have this, right? I can now use SSS. Check it out, I can now use SSS because in step 1, we were told that two sides are congruent. So there's one. And in step 2, we were told, we were not told, but we were able to deduce through the reflexive property and seeing that in the diagram here, that we have our second pair of sides were congruent. And then finally, in step 4, we were able to determine that our third pair of sides were equal to each other. So we have one pair of sides, we have two pair of sides, we have three pair of sides in two triangles. That is the SSS postulate. SSS postulate of determining that two triangles are congruent. So let's go ahead and wrap that up here. This will be a 5-step proof. And feel free to come by. If these proofs are giving you trouble at all, feel free to come by and we'll talk through this. We'll go through the steps. You just got to go slowly. And again, the only way to get better at proofs is by doing a lot of them, right? Doing a lot of them and asking for help and keeping reaching out in this one here. Okay. This one's SSS. And we know that we are done because we have proved this fact that triangle POA has got to be congruent to triangle POA. Okay. Starting with those original premises that were in this given statement, saying other logical things along the way, we finally gotten to our conclusion. How do I get from the beginning to the conclusion? How do I get them to connect? Well, that's the beautiful puzzle of this all, and getting those answers down here. All right, folks, cool. We're going to keep this in mind here for number 17, which will be the last one we do to get together today. So that was sort of doing a proof. That was the last one on your homework right there. Again, just an example of doing proof, practicing proofs. I know it takes a while to feel really confident on those. Usually till the end of this chapter, people are just like, when it comes to proofs. And even still, proofs are hard after that. But yeah, like if you keep these 4 things in mind, it should make it a bit easier. It should make it a bit easier here. Okay, here's number 17. 17 is fill in the blank proofs, okay? Fill in the blank proofs. But what I'd highly recommend for this is don't really think of it as a fill in the blank proof. Think of it as a puzzle you need to figure out where you're going to use similar strategies to what you have here. Use previous proofs for how to do it, okay? What does this look like here? Well, we got to get triangles congruent to one another. So what are we going to use? We're going to use either SSS, SAS, or ASA, because those are the 3 postulates we have so far to get one triangle congruent to another triangle. So we're going to use one of those because it looks like that is what we need to prove. Okay, so we're thinking about previous proofs. We're also, and something like this, mark up the diagram. So it says just complete the reasons, but if you just spend a minute marking up the diagram, it's going to make your life so much easier to fill in this stuff here. Because you'll actually be thinking about what, like, I hated fill in the blank proofs when I was in high school because I would just look at it and be like, I don't have the answer right away. Does that sound familiar? Right? When you just look at it and you're like, oh, I don't know how to do this. I'm going to give up. I'm not going to do it. Yeah, no, don't do that. Listen to me here. Like, listen to me here. Mark it up. What do you know? Segment RS is perpendicular to segment ST. I'm going to mark that up. Boom, we're good to go. TU is perpendicular to ST. TU is perpendicular to ST. Just get it done. Get it down on paper. Helps you out a lot here. V is the midpoint of segment ST. Yes, it is. So I'm going to mark up that these are congruent. So we're probably going to say that at some point in time. And how would I get these two triangles congruent? Guys, this is all about marking up your diagrams. I would mark up your diagram first and then write the freaking thing afterwards, right? I'm going to get them congruent by ASA. Yes, ASA. So you can actually see how this proof is going to be written just by marking it up right away. Mark it up, mark it up, mark it up, mark it up. Please, 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 please mark it up. Just don't just like, I don't know how to do this. Mark it up, okay? ASA. There it is. Like, just rest assured here. All right. So I want to reward you guys who are listening to these things and marking up and using those strategies and getting yourself good to go here. All right. Anyways, this is clearly a given premise. Okay. This is a given premise right here that we have down here. So this is going to be given. Okay. Notice here, they haven't said V is the midpoint of segment ST. So perhaps I'll look for that one to get that one in here. Okay. So they break up their given premises a lot of times when they're writing proofs for you, because they're going to use these step one. They're going to use this to get to step two, right? They're going to use this to get to step two. So sometimes they break it up. So they say these two ideas go together, and then these ideas kind of go with everything, but at least this will probably get us to that. Okay. And I just wanted to point that out. But anyways, this one is given premise. They broke it up. They use this other given premise in step three. So that's how I usually start these, is I fill in my givens for these fill in the blank proofs right here. Okay, so I need to fill in some information. I know that the reason why they wanted to put this given premise here first is because it's going to help us say something helpful down here. Remember, so I know I'm going to say ASA right here because RS is perpendicular to ST and TU is perpendicular to ST. So what they are trying to say in order to use ASA is that, look at this here, they're perpendicular, right? They're perpendicular, but are they congruent? Are they equal to each other? Well, just the fact that they're perpendicular and whatnot, that's not enough to prove that two triangles are congruent. You need to say more than that. Why are they congruent? Well, this, right, is perpendicular, so it's a right angle. Okay, that's the definition of perpendicular, is if you have perpendicular lines and they form right angles. And they also measure of angle equals 90. Okay, and that's the same for this, and that's the same for this. Okay, so here, definition of perpendicular lines and definition of right angle is enough to say that measure of angle S equals, well, is a right angle, which equals 90, and measure of angle T. Okay, measure of angle T is what we're going to put there, because that's the other angle. Those are the ones that we want to get congruent to one another. This one and this one, we can get there because they're both, those lines are perpendicular, so they're both right angles. Right angles both measure 90. And if they both measure 90, then they both equal the same measurements. They're equal to each other by transitivity. Okay, so that was what we have here for this one. All right, so now we have an angle stated here. That's all we've stated through step two. So let's get the side now, and then we're going to do vertical angles congruent later at some point. So we got V is the midpoint of ST given. What's that going to connect to? What's that going to get us to? Well, V is the midpoint of this. We're going to get SV is congruent to TV. Okay, and that is the definition of midpoint, right? A midpoint creates two congruent segments out of that one big segment that you have there. Definition of midpoint. Got it. Laying out that argument. Getting to that proving the two triangles are congruent. All right, checking one out here. Last one here. Whew, let's get this. That angle is congruent to that angle. That side's congruent to that side. And then again, I put this in green right here. Those two angles are congruent because they're vertical angles. They are freaking vertical angles. Are congruent. And this is RVS is congruent to UVT. And there we have it. We get the end of this proof. And We could match up the correspondences if we want to here, but we just trust that they did that right for us here right now. So step 6 has got to be what it is we're trying to prove here. Reason why we're able to do it, ASA. Hopefully you noticed that when you went through it. So I'm going to do this, ASA, and I'm going to match up what we see right here, RSV and UTV, and we're good to go. Proofs, baby, proofs. Proofs get a little bit more easier like this because these should feel maybe a tiny bit easier, I'm hoping, than like chapters 1 and chapters 2 proofs. And we're able to do a lot of them, zip through them, and feel like we're accomplishing things by getting us some new facts. If given all this information here with these perpendicularness and a midpoint, yes, we can do the work to prove that those triangles got to be congruent to one another. Pretty powerful thing, these fact finding missions we have here. All right, go ahead and email me if you have any questions. Rise and shine and enjoy the rest of your day. Bye, guys.